Okay, I should be live on. Yes, I'm live on both Twitter and YouTube. Let's see. Okay, not sure if I'm audible on Twitter. Okay, I'm audible. Let me reset the timer. 1 hour for our today's stream. Okay, ignore this. Yesterday we wrote two tests, just checking out different things. Oh, what was this? Okay. Yes. So next part will be writing R. This is done. Staked say. I don't think that anything else is needed here. We can move on to our actual logic, staking logic. So contract liquid staking. Okay, I'm back. This now what do we need here? Let's plan first. We need following functions. First will be what is the first function? First, like deposit. We do need that. We need withdraw. These are user related functions. Fun- functions for user. Functions for users. Now we have delegation bot, right? So functions for delegation bot. We will have delegate, undelegate, and redelegate. So we'll just we will use these three functions and manage at least these two. um, Delegate and redelegate will be used in like maintaining the strategy, delegation strategy, whatever it is. In case if validator gets like slashed, then we need to redelegate uh, those tokens to some other validator, right, to get that reward. So that's where these two functions come in. Undelegate will be just to remove tokens whenever user requests it. Then we have access control functions. Bo- Let me check the access control, like how they name it. Only role supports has role, check role, get role, grant role. Okay. we can say set bot remove bot. Then we have we'll have one more function which important but not sure which category, which is exchange rate. This function will calculate exchange rate between these two things. These two things in the sense actual say native token and say the our stake token. So those two functions. Let me what else do we need? We need something else? I don't think so, but still, if we do need something, we'll add it afterwards. This will also be owner two step, and we can try and give access. Sorry, we'll try to use multisig. I haven't worked with any multisig, so this will be a good exercise for me also, where I can actually work with the multisig. Yeah, I don't think actual multisig is the issue. Like, um, it just will set up a what I wanted to say. Yeah, we'll set up something here. Set the owner will call it. So multisig contract will call these two functions, right? In our contract, we don't have to do anything if we are using multisig or single EOA. Yeah, like MetaMask or something like that. So we don't have to worry about it. We just have to like add it here and use the what was that, their UI maybe, and see how that UI works. That would be interesting. Okay. Yeah. uh, I was saying about the multisig, right? So if we are using multisig, we just have to construct the call data on their front end, and then sign from multiple wallets. Okay, let's start with this. um, we need a constructor, and we also need to set in the constructor. We need to do bunch of things. Constructor let's say first thing, set state say token address. Next, set owner. What else do we have? No, do we have? I didn't want to say do we have. What else do we need? I don't think we need anything else. Okay, so let's take address, token, address, owner, and we can set them here. We'll do address, sorry, address immutable s underscore token. Now here s underscore token will be owner, sorry, token, and we need to import ownable, right? Import ownable @open zeppelin / contracts / access control, no, / access / ownable, and down here ownable two step is ownable two step base constructor. We have to fulfill that ownable owner. Okay, done. This is done. Now first function we want to create is exchange rate, because everything else depends on it. Not everything else, these two functions, user related function, depend on this, the exchange rate, this part. So what we want to do is actually let me give me a second. Profile, I'm just referring to project I built previously and how that's okay. Yeah, so in the exchange rate function, we'll just right now we'll say underscore get underscore exchange rate equal to internal view returns UN 256 and return 1. For now we can have this. Next part is we'll we'll look at this at the end, not at the end, but first we can use we can build sorry we can write these two functions and then move on to, after that's done, we can move on to understanding exchange rate. Function deposit. For deposit we don't need anything from user because we already have address of the user with message.sender and value of the say, how many say tokens they have sent with message.value. So sorry external view, external, that's about it. Now we need to will mint the tokens based on exchange rate. So if user deposits some token, we have to give liquid staked LSTs. So liquid stake token appropriate amount of, so equivalent amount of those tokens. How can we calculate that? Okay, that's pretty simple. It just token mint amount we can just create with this UN256 tokens to mint equal to message dot value into the exchange rate. Get exchange rate. Oh, we need to make this payable, and we need to import our say our state say contract, state say source slash state say dot sol, and we'll change this to state say. No, state say, and now we can mint it. State say dot mint. We have mint function, right? State say mint, we need address and the amount. Address will be message.sender comma tokens to mint. No, s underscore token. We need more descriptive name. S underscore state say. What else? Now withdraw. So yesterday we talked about withdraw function, right? Where we can't actually just return any amount. We need to wait for wait for the unbonding period, and then give the give the native token back. Otherwise we will be in deficit. Yeah, we can't be in deficit anyway, but you understood what I wanted to say, right? Okay. uh, Chat. Yeah, we so will in withdraw, no, not withdraw, deposit, withdraw, and undelegate. So there will be three functions. User can call this after the what's this, after the unbonding period is over. User can create a undelegate request. So bot can remove some tokens from delegated validators based on the strategy. Okay, this is good. And here it is the same. Deposit the tokens. Sorry. User can call this function to deposit tokens and get equivalent amount of LSTs back. So now we can work on function withdraw. External, no one will send anything here. And function undelegate, yes, probably undelegate should work. Undelegate, what else? We need amount. UN256 amount. External, yeah, that works. Here I want So person can create like multiple undelegate requests, right? I want to make sure it doesn't like just fill everything up. Yeah, and the application contract I have built previously, what I am doing is for undelegate request, I am creating a mapping. First, for first value is address and second value is undelegate request, which is a struct. The struct has three values: exchange rate, amount, and timestamp. So we can check when the request was made and accordingly withdraw all. Sender undelegation request. Sorry. Yeah, this one. I was just checking out this where I have this mapping on line 61. I have this struct and withdraw has this. We have push. Oh, okay. This is pretty clever. Where pretty clever in the sense I was also thinking about the same thing. Uh, the size doesn't reduce. Uh, sorry, size of the array doesn't reduce in the solidity. Like you have to do something. Here, what I'm doing is whenever I remove or like whenever a withdraw request is successfully executed, I'm replacing that request with length -1, uh, last element of the array. So there are two copies of that, and then I'm uh, removing the last element. So size is reduced, everything is there. That's pretty clever. And in any case, on front end, like we can handle this. We are, if any user has like 100 tens of requests, we can handle which request to send here. Sorry, which request index to send here in this, which request index we can send to withdraw function. We can handle that on the front end instead of doing it ourselves. Sorry, instead of doing that on the whatever this is on chain. Sorry. Yeah, Okay. Yeah, we should follow this only. There is also amount minimum amount to stake. For some reason, minimum amount which is zero point 0.5 ether, so zero point 0.5 ether which will be zero point 0.5 say on as we are building it on say. Yeah, I don't want to take reference from it, but okay, let's start with creating. No, let's start with the minimum say amount. Can we refer to one of the liquid staking application? I know Milky Way, Celestia. Do they have minimum like minimum amount to stake? Okay, I no, I don't want stake TI. We have that. Exchange rate we also have that. Okay, we don't need minimum stake amount. $10 million liquid staked. That's pretty cool. We have this to build, right? This like exchange rate function we still haven't built it. Right now it just returns 1. Okay, no minimum amount needed. We can cut this then. Okay, mint. We have internal. Okay, this function is done. We can say done. Next is undelegate, and here we'll create the undelegation request, right? So we need a struct and a mapping. Struct with draw request. First will be the amount UN256 amount a amount. Okay, then UN256 exchange rate, UN256 timestamp. Now we can create mapping. Address with withdraw request array private s underscore score withdraw requests. So now we need one more function. Function get withdraw request. So address for no account, or we can say user, yeah, user, then public view will have return value here. That return value will be the array, the whole array. Okay, let's start with, instead of undelegate we can say create withdraw request. Yeah, so more descriptive name, that's what I want. Ignore this. Okay, more, what was that? Oh, hello, who's, hey Chandar, building on oh sorry I didn't see your message in time. Yeah, building on say liquid staking application. I have built this previously but decided like I can have a live stream also about that, why not? So you can check on my profile too. This was the application that I built. Also, liquid staking application is pretty simple to build. That's why I wanted to build it. I thought it would be more difficult, but yeah, it's like 300 lines of code and bunch of tests. The same thing I'm trying to build, recreate on live. Just keep just polishing my skill. That's it. Yeah, cool man. Thanks for joining. Yo. Also, this is my other account. I'm I'm replying to your comment, and that's the other account that I use on daily basis. Okay, sorry. At the rate Chandar, thanks for joining. Okay, back to working on this. First, we need create withdraw request. That's that's great, but we want to check when they create withdraw request. We want to burn the tokens also. So create with first like burn tokens, create withdraw request. Don't burn it, transfer token to account. Why? Because if we burn those tokens, our exchange rate will change. Even if it's for few hours, like the bot will run periodically, right? So it will run once an hour or once every 2 hours. But if in that time period someone checks the exchange rate and we have burned the token, that will change the exchange rate slightly. It won't be that big of a difference, but if some big account like tries to do this, then exchange rate will fluctuate. Exchange rate won't reflect the correct amount. Okay, uh, next, what was next? This transfer tokens and create withdraw request. Yeah, I don't think that there is anything else. We can have event here, but that's not very useful. S underscore state c dot transfer from message dot sender comma to address this comma amount. Okay, transfer from. Can we also use like save was the issue? Okay, that's let's go to ERC20. ERC20 control F save. Transfer from don't tell me that there is no safe transfer from, or it was in the old like previous versions. Skips mth approval event. Okay, transfer from address to. Okay, this part is correct. Now we need to create a withdraw request, which will be s underscore withdraw request. Now let's first create that request. Create request and push to array. Can we actually, let's start with withdraw request memory withdraw request equal to withdraw request. First part is amount, we can say amount, then after amount we have exchange rate, we can say get exchange rate, and last is timestamp, block dot timestamp. Cool, we have this. Now we can push it to the array. What was this? Okay, exchange, no, s underscore withdraw request message dot sender dot push and say withdraw request. Does this work? Yes, we'll test it actually. Now we need get withdraw request, right? UN256 request index, we can say request index return s underscore withdraw requests user request index, and we also need to say returns withdraw request memory. Not very fancy, but yeah, this is one of the functions. Now for actual withdrawal request, actual withdrawal, we'll take UN256 index. Okay, index will first what should we do first? First part will be send the tokens. Copy the request, remove the request, send the tokens. So withdraw request memory request equal to s underscore withdraw requests message dot sender index. Now to remove this request from the array, we'll do withdraw request message dot sender comma index equal to s underscore withdraw request dot not dot message dot sender now we need length. UN256 length -1 done, and now we will say message dot sender dot pop. Now actually sending the part where we actually send the tokens. We are doing boolean success. We can ignore the second part for now. No, we don't need to. Memory data can you say message dot sender dot call. Yes, we can. Just we need to send the value will be request dot amount into request dot exchange rate. Okay, at the time of withdrawal, we don't need to set the exchange rate. That's what I'm saying. Uh, it will create is that so there will be some miscalculation at some point here. We are creating a withdraw request with exchange rate. No, there won't be. I don't. I don't really think so. So when the actual undelegation when the actual undelegation happens from the bot, this yeah, undelegation happens, then only the exchange rate will change. But till then, exchange rate will be the same. So we don't need this part. Amount will be underscore exchange rate. We can remove this. Okay, that's great. Success. Transfer failed. Create custom error. No, we can just create. Let's start with creating custom errors now. Okay, remove this. Structs will have errors at the top. This will be liquid staking underscore underscore transfer in withdrawal. Sorry, transfer failed. We can just say that, then bytes data. Can we say liquid staked data? Oh, okay. Uh, is it because we don't have? I think we don't have this custom error. We can't use custom error with require in 8.0.8.21. Emit expression. No, revert. Can we write that in one line? Yeah, we can. This is correct. We also need one more function for getting get withdraw requests address user public view returns withdraw requests array memory return s underscore withdraw requests user. Okay, this part is done. So we have worked on this part, this all the user related functions. Let me copy this. Okay, all of them, we have completed all of them. Now we can move, we should write unit tests maybe for this part. Yeah, let's start with unit tests. New file, liquid staking test dot t dot sol pragma yeah pragma. Then what's happening on Twitter? Do we have any? No, we don't have any viewers. 0.8.21. Oh, cool. Someone actually watched the Twitter stream. Import test for std slash test dot sol contract liquid staking test function setup public we also need to import those R2 contracts. Import liquid staking source slash liquid staking dot sol. Oh, so not capital S. Import staked say source slash staked say dot sol. Now we need three different things in the global variable. We need address, private owner, then staked say, staked say, private s underscore staked say, and liquid staking private s underscore liquid staking what else do we have? No, we need to start with actually implementing it, which is start with s underscore owner, make address. Now we need to deploy state say. Accept ownership. Okay, this is interesting. To deploy our staked say, we need address of the owner, which is liquid staking contract. But to deploy liquid staking, we need address of staked say. So we'll first deploy staked say. No, we will first deploy liquid staking. What's okay? Uh, we'll first deploy liquid staking with random address of the token, then transfer the ownership to no, we can't do that. I want to say first deploy state say. The owner will be our contract, our test contract, and then okay, ignore this for now. We'll write this tomorrow. We are already over the time limit. Okay, cool. Uh, I hope you like the stream. You know what we did today, which is writing the whole user related functions of liquid staking, withdraw, create a withdraw request, and deposit. We haven't tested them, so pretty sure there will be one or two bugs. We'll do that in tomorrow's stream. Okay. If you have any ideas to improve what I'm doing on stream or any review, review, generous word. Um, if you have any thoughts on how I can improve stream or what's good, what's bad, let me know in the comments or in the Twitter DMs or wherever you want. You can find me anywhere on Twitter, YouTube, LinkedIn. Okay, that's about it. And yeah, I'll be happy to take those reviews and improve my stream. But anyway, hopefully you like the stream. If you like the stream, please do follow on Twitter, subscribe and like on YouTube. It gives me a little ego boost. That's why. There is no other reason than that. Okay, have a nice day and see you guys tomorrow, same time. Bye bye.